unit, we're going to be talking about kinetics. Kinetics is basically how fast a reaction happens. So in this particular video, we're going to talk about how to speed up a chemical reaction and what really happens in a chemical reaction that makes it slow or fast. Well, before we get to that, a long time ago, I had a weird encounter that led me to conclude something about how to get a date for prom. So basically, a long time ago, I was working at a different school. In the school, there's a courtyard, and there was a little area above the courtyard that people would walk to get to their different classes. So you could actually see people down in the courtyard from this area if you were moving to your classes on the second floor. Well, this particular morning, I happened to be moving between my room and the place where they kept the printer, and I had to keep moving back and forth for different reasons. I forgot paper at one point, but anyway, what I noticed because I was moving back and forth was there was this boy who was just sitting right above the courtyard. So he was just sitting on this little area watching the courtyard very intently. It's a little creepy. So I was moving back and forth and he was just sitting there. Well, at one point when I was moving back to my room, I noticed somebody was walking through the courtyard, and there was this girl, blonde girl, walking through the courtyard. Well, as soon as she started coming down the courtyard, he jumps up and runs downstairs, and then he just kind of waits for a second. Well, I decide to see what's happening. I don't know what's happening. It looks weird. So he ends up accidentally bumping into this girl. So they have this little collision, and her books go everywhere because she's holding her books. She didn't have a backpack. I don't know. And then he was very polite. He was like, let me pick up your books for you. Anyway, months down the line, they ended up going to prom together. So I ended up concluding something about getting a date for prom. Really, if you want to get a date for prom, hit girls. Just go and hit girls. But, I mean, you have to do it in a certain way. I mean, this one was stalking her, apparently, and then he bumped into her. I mean, you can't, like, go and just hit the girls in the face. You have to basically hit them in a certain way. So it made me think about how we can increase the number of prom dates. Well, one of the things you can do is you can decrease the time in halls. So if you do that, then you have people moving faster, and there's more chances for a collision to happen. You could also decrease the space in the halls. Well, if you have less space in the halls, then you have more collisions happening between the girls and the boys. Then you can also bring in more girls or more boys. You can get a matchmaker. You could get somebody to help do the stalking for you. Or you could also make sure that you don't travel in packs. So if you have a group of girls, well, it's going to be hard for them to have a collision with a boy. So these are some things you can do to actually increase your rate of getting a prom. If my theory is correct, getting a prom really involves hitting girls. So what does this have to do with chemistry? Well, really, in order for a reaction to happen, you have to have a perfect collision. So it's the same kind of scenario. So your rate of reaction, so in chemistry, that's the time for a reaction to take place. To make a product, the reactants need to collide, and they have to collide in the correct orientation, and they have to have enough energy. And it would be the same thing for getting a date for prom. If you're going to collide with a girl, it has to be in the perfect way. If you can't just go and slam your book into their face, that's not going to get you a prom date. So it has to be in the correct orientation. So if you have a molecule, it has to be oriented in a certain way, and they have to have enough energy. Otherwise, they're just going to collide and bounce away. And this is all part of something called the collision theory. All right, so if you want to increase a reaction, you're going to increase the temperature, which is basically like decreasing the time and the halls. Because if you increase the temperature, you're going to increase the kinetic energy, and there's going to be more likely a collision that happens with enough energy. You could increase the pressure, which is decreasing the volume. So if you decrease the space that your reaction happens in, there's more chances for the collision to actually happen. You could increase the concentration of any of the reactants. You could add a catalyst, which is like a matchmaker. It lowers the energy you need to make a reaction happen. Or you could increase the surface area. So if you increase the surface area, one of the ways that you can do that is to crush something up, cut it up, make it into smaller pieces, and that actually increases the surface area because it increases the amount of surfaces that could have collisions happen. All right, so when we look at a reaction, this is what the energy looks like during the reaction, and it varies based on whether it's endothermic or exothermic. So in exothermic, the products will have less energy than the reactants. In an endothermic reaction, the reactants will have less energy than the products because you're putting energy into the system in this one. And for an exothermic reaction, you are releasing the energy from the system. So the products should have less energy. So when you look at this little hump right here, this is called the activation energy. And it's in every type of reaction. So that hump right there is the energy needed to make a reaction occur. So that little hump is going to be your activation energy. So from the reactants to the top of the hill. So in this case, the activation energy is much, much higher. So at the top of this little hill, we have something that happens, and it's called a transition state. So that transition state is basically the reactants coming together and making this uniform thing. Basically, it's what happens before you actually get your products. So they're colliding together, and this is called a transition state. Well, reactions actually happen in steps. So sometimes there's just one transition state, sometimes there's multiple transition states. If you add a catalyst is going to provide a new pathway for this reaction to happen. So basically the catalyst provides different steps for the reaction to happen, so that will lower the energy necessary for the reaction to happen. So when I look at this this potential energy diagram, you need to be able to tell whether it's endothermic or exothermic. You also need to be able to tell where the activation energy is, so it's little hump. You need to be able to tell where the transition state would occur, so the top of the hill. And you also need to know the energy released and the energy absorbed here. Okay, so when we look at this right here, between the reactants and the products, the difference between the reactants and the products, that would be the energy released here. It's released because, well, products have less energy, so the energy has to go somewhere. It gets released into the atmosphere. Well, right here, the difference between the reactants is here and here. So that difference is the energy absorbed. And notice that it's not the same as the activation energy. We actually need more energy to start the reaction than we actually put into the whole reaction. Now, if I were to add a catalyst here, it just changes this hump, the activation energy. It does not change how much energy is released or absorbed in the reaction. So if you see one of these, you need to be able to identify those couple of pieces of information. All right, so in a reaction, you have different steps. We call them elementary steps because those are the simpler steps in a reaction that add up to the whole thing. So if we have just one step, here are reactants, here are our products, and at the top we have our transition state. So basically the reactants are combined together in this one big, huge clump, and we haven't made the products yet. Now, if we had a two-step reaction, we would have a transition state here and here, so at the top of the hills. So right here, I have one step of the reaction. I make some products. Now this product ends up getting used in the second step, and then we make our ultimate products here. This is called an intermediate. So I've made something else. So I've made a product, but it's not our ultimate product. So it's in between our first step and our second step. So it's called an intermediate. Now, elementary steps, they can fall into 3 different categories. So most reactions will take place in multiple steps, and we have different categories of our elementary steps. We have unimolecular, which is where you have one molecule that reacts to form another. That's called a first order reaction. We have a bimolecular, which is where we have 2 molecules that react to make products. So I have one molecule here, and they react and collide together, and that's called a second order reaction. It's called a second order reaction or bimolecular because there's 2 reactants that collide. And a trimolecular would be where you have 3 molecules react to form a product, and that's called a third order. So I have 2 molecules of NO and 1 molecule of O2. They have to all collide together to make the reaction happen. So your elementary steps can either be involving 1 reactant, 1 molecule, 2 molecules, 3 molecules, and it goes on from there, but really we're just going to focus on first order, second order, and third order. Now inside a reaction, you have different steps. Well, the different steps that you have, that's called a mechanism. So the sequence of steps that you have is called a mechanism. Now these steps can either be really fast or they can be slow. The slowest step is the most important, and that's called the rate determining step. So the slowest step is the rate determining step, and that determines the entire speed of the reaction. So it determines the speed of the overall reaction. It doesn't matter if you have 5 steps or 3 steps, the slowest one is the one that determines the speed. All right, so let's look at a reaction mechanism. So this is our overall reaction right here. This reaction actually occurs in 2 steps. One where the NO2 molecules are colliding with each other to make NO3 and NO. And the other is where the NO3 molecule right here collides with the CO to make NO2 and CO2. So it has 2 steps. This is our overall reaction, and we're going to get CO2 and NO at the end, but it happens in 2 steps. This is our slow step. So really, this is what determines the speed of the reaction. So our rate determining step is what actually determines the speed. This will happen in milliseconds, so it really doesn't affect the speed that much. This one does.